Good day once again. Welcome to one session of my channel. Today we'll be talking about errors in measurement. If you don't subscribe to our channel, do so right now. Click the subscribe button as well as hit the notification bell so that when we post a new video, you will get a notification on the new video we posted. Okay, so errors in measurement. All researchers, all experiments, and as well as all lab works actually have a bit of error in each of them. There's always a bit of error in each of them. The error may come from the instrument or from the person carrying out the experiment. Now, that leads us to the two types of error, which is one, the systematic error, and two, the random error. Now, the systematic error is a type of error that is gotten from the instrument itself. So, for instance, now you have an instrument that is faulty. Now, you don't expect to get an accurate value from that particular faulty instrument. So, you get an error in your reading or an error in your experiment. That is known as the systematic error. It may be an error in the ruler, it may be an error in the calibration of the ruler, it may be an error in whatever experiment you are carrying out in the lab or in the field or whatever. If the machine or the equipment you are using is faulty, then automatically you experience error. That is the first type of error, known as the systematic error. And the second type is the random error. That is the error which you yourself may commit in the process of taking that reading or process of carrying out that particular practical. Now, this random error is not gotten from the instrument, it's gotten from you yourself. For instance, you may be short-sighted or long-sighted, or you may miss your count when taking calibration, or something may just occur that you have a particular error in that your particular experiment, maybe taking reading or the rest. Now, that is the second type of error, random error. Now, how are you going to solve this issue of error? How are you going to resolve this issue of error in your experiment to make sure that your experiment is not, because an experiment cannot be error free, but at least you know that the percentage of error in that particular experiment is not high. At least if you carry out an experiment and the percentage error in the experiment is 30% and below, then you know you've already carried out an almost accurate experiment. But if your percentage error is above 30%, maybe say 40, 50, 60, 70, or 100% error, wow, that means your experiment has not gotten anywhere. You have to redo that particular experiment. So how do you know, how do you calculate the error in your experiment? Let's say you carry out an experiment, for instance, using a ruler. Now, the ruler is calibrated in meters, and the meters is in calibration of 1 meter each. So let's say our measurement for the ruler, let's say you take a measurement for your particular ruler to be 7 meters, and the ruler is calibrated in 1 meter each. That means we have an error of plus or minus 1 meter. Now, let's say you take an experiment with your pipette. No, let me not say. Let you take an experiment with your burette, and your burette is calibrated in centimeter. Let me say your fluid in the burette now got to a volume of let me say 60, or no, let me not say 50. Got to a volume of 30 centimeter. 30 centimeter, and the pipette, the burette is calibrated um in 0.1 centimeter. 0.1 centimeter. So we have an error of plus or minus 0.1 centimeter. So that means if you are to make an error in this ruler, you are going to make an error of plus or minus 1 meters. And if you are to make an error in this burette, you have to make an error of plus or minus 0.1 centimeters. So how are you going to calculate your percentage error to know if your experiment should be repeated or it should be gone ahead with? Now let's see how. So let's consider a meter rule. So let's consider this meter rule. Now, this meter rule is a section of the complete meter rule. Now let's say the meter rule is calibrated from 0 to 50 cm, but this particular part that is not shown is from 0 to 15, while this part above here is from 25 and above. But this is just the area we need to consider. That's area under consideration, which is like our 6 term when we talk about thermodynamics. If you don't know about thermodynamics, check our video on thermodynamics and you will be able to understand what I mean by area under consideration. That is our 6 term. So this is our system we are considering. So we are considering from 15 to 25. Now this particular rule is calibrated in if this is 15, the next and this is 20. That means each line should be what? 0.1 should be 1. Sorry, each line should be 1. That means this one is 16, 17, 18, 19, then 20. That means each particular calibration is 1 cm. So automatically we are having the error to be plus or minus 1 cm. So if we consider this first point to be our point A, I'll consider the second point to be our point B. Now, what is the reading of point A? This is 15. This next one is 16, 17. This next one is 18. That means between 17 and 18 is what we have as point A. That means point A should be 17 and half, 17.5. That's what we are reading because it's between 16 and 18. It's between 17 and 18, so it is 17.5. Now let's consider point B. Point B is 25. It's after 25. It is not yet in 26 because there's no calibration there after. So that means our B is 25.5, and we have our error as plus or minus 1 cm. Now, how do you calculate the error in this reading? For instance, we're taking this reading of point A and point B to be 17.5 and 25.5 cm respectively. Now, how do we know if this particular reading should be taken ahead with or it should be repeated? Now we have to calculate the error, and I told you how to get the error. The error is just the calibration in the particular instrument you are using. The difference in the calibration, the particular instrument you are using, gives us our error. So how do we know our error for A? So the first step is to look for the average value between these 2 points. Now the average value is going to give us the difference between B and A. So our average value is equal to B minus A because B is the larger part and A is the smaller part. So we have it as B is what? 25.5 minus our A is what? 17.5. Now the next step after getting your average value of these two is to get the maximum value. So let me just explain the step. First of all, we get the average value. Secondly, we get the maximum value. And third, we get the minimum value. Just like this. This is our reading now. We get the maximum value. We get the minimum value. Then we get the average value. That's how you know the error. So when you've gotten these 3 parameters, you'll now be able to calculate for the error as well as the percentage error. So now we've gotten the average value. The next is to get the maximum value and minimum value. Now, how do we get the maximum value? The maximum value is the longest value. That is the maximum. That means it's going to be the highest value of B minus the smallest value of A. That's going to be the maximum value. The highest value of B should be 25.5 plus 1. That's 26.5. That's the highest value of B, 26.5. While the lowest value of A should be 17.5 minus 1. That's 16.5. So our maximum value will now be 26.5 minus 16.5. Now, I've told you how we got 26.5. This is 25.5, which is our value of B, plus 1. Plus 1 gives us 26.5. That means the maximum value of B minus the minimum value of A now is 17.5 minus 1. So for A, we are removing 1, which is the calibration. For B, we are adding 1, which is the calibration. So we have 26.5 minus 16.5. We have it as 10 cm. So the next is to get the minimum value. Now the minimum value will become the minimum value of B minus the maximum value of A. So the minimum value will become minimum value is equal to the minimum value of B should be what now? Yes, 25.5 minus 1. So we have it as 24.5 minus the maximum value of A should be what now? 17.5 plus 1. So we become what? 18.5. So you see, for the maximum value, we are using maximum value of B minus minimum value of A. While for the minimum value, we're using the minimum value of B minus the maximum value of A. I think I should write that. This is maximum, this is B maximum minus A minimum. Now for minimum value, we have it as B minimum minus A maximum. That's the formula we are using. Why this is just B minus A there. So 24.5 minus 18.5, we have 6 cm. So now we've gotten the average value, we've gotten the minimum value as well as the maximum value. So how do we know our error? How do we calculate for our error? Now the error is going to be the maximum value minus the average value. Or if you want to consider using the minimum value, it's going to become the average value minus the minimum value. They will give you the same answer. I repeat myself, the error will now become the maximum value minus the average value, or the average value minus minimum value. From this my chart here, I have maximum minus average, so this gives me my error, and also this gives me my error. I will get the same answer for both of them. Whether I use maximum minus average or I use average minus minimum, they both will give me the same answer for my error. So let us consider maximum minus average. So we have our error is equal to B is equal to maximum value, max, minus average value, average. Our maximum value is what? 10 cm. So we have it as 10 cm minus our average value is what? 8 cm. 8 cm. That's what? 2 cm. You can try it for average minus minimum if you get 2 cm. So you tell me in the comment section below if you actually got 2 cm. If you don't get 2 cm, then I've made an error. But if you get 2 cm, automatically the formula is mathematically proven and correct. So that is for the error. Now how do you get the percentage error? The percentage error now becomes this error over the average value times 100%. That means this error, percentage error now, will become error over average value times 100%. What's our error? 2 cm. So give us 2 cm over, what's our average value? 8 cm. 8 cm times 100%. So that will give us what? That will give us 25%. So we have our percentage error to be 25%. Is this particular experiment good to go, or we need to redo the experiments? Tell me in the comment section below. I've already explained to you how you know which of them is good to go, how you know which of them is due for repeat. So 25%, is it good to go, or we need to repeat it? You tell me in the comment section below. So that's how you know percentage error. So we can take another example on percentage error. So if you have another example or a question on percentage error you want us to calculate, or maybe you've carried out an experiment and you want me to calculate the error in your experiment, kindly send it to me in the comment section, or check our WhatsApp or our Facebook page, learning area, so we'll be able to check if your experiment is good to go or you need to repeat that experiment. You just have to, or you can do it on your own. Just follow the steps I've given. Look for the average value, look for the maximum, the minimum value, you do the subtraction, then you do the error, percentage error. If it is more than 30%, then you need to repeat the experiment. But if it is less than 30%, then you are good to go. That's how you know if your practical or your experiment or your research is actually 90% accurate or close to 100% accurate. So if we are to calculate error, this is for errors in addition or subtraction, just in normal. But if we are having a quotient or multiplication, I will show you how to get the percentage error as well as the error in that particular kind of equation. For instance, you have something like the force is equal to the mass times the velocity square over the radius. What formula is this? Tell me in the comment section below. This formula, tell me in the comment section below. So if you have a question like this and you have to calculate the error in this particular experiment, there is another approach to calculating the particular error in this particular experiment. It's not different from this, but there are slight differences when you have quotient and multiplication. So how do you know about it? You check our video on errors in measurement when we have quotient and multiplication, for you to be able to calculate when you have something like this. You can calculate the error when you have something like this in your experiment. So thank you very much. See you in our next class. Don't forget to subscribe, don't forget to like, and don't forget to hit the notification bell, so when we post a new video, you'll be among the first sets to get it. So thank you very much, and do have a nice day.